Hello everyone, my name is RONAK KANTHALIYA and today through this video I am going to tell you about our project in making for the welfare of the agriculture society or more specific for the farmers. The product is automatic pesticide sprayer. Without getting late, let's jump to the first topic. Comes the introduction. As we know that 70% of India works under agriculture sector. After listening this, the first thought comes in the mind, if 70% of India works under agriculture sector, then they might be advanced in this field, but it is not. I will take an example. Take the example of pesticides. Pesticides are widely used in this sector in India and many other countries too. It's good that these pesticides kill or control the pest, but there are many farmers who die due to the poisoning through these pesticides. These pesticides are that much toxic that they are harmful for the human body too, and they are harmful for the environment. So this robot works for farmers. The main task is to spray pesticide in irrigation system. The whole robot is designed on 4-wheel car based mechanism and controlled through Bluetooth sensors. This works on 33 volt. It is divided inside like 12 plus 9 DC battery life. And one more important point, it is affordable, less cost than robot system. Now we will talk about the components required for this. Now let's see what are the components required. In this 3 RF modules are required, different, like one single pin, one triple pin and one 4-pin RF module is required. 5 DC motors are required, like 4 for the wheels and 1 we are using a robotic arm for the camera and all the picking stuff. So 5 DC motors, 1 camera for watching around, 2 ultrasonic sensors for both the sides, 1 battery to control the unit, a sprayer system which might be containing a nozzle in front for spraying the pesticide, and 1 tank which containing that pesticide, and 4 tires for the base. Now let's jump to the next topic. Now comes the product specifications. In this product specifications, we are going to talk about technical aspects of product. First, it operates on 3.3 voltage DC. Low power consumption takes place. Operating frequency of RF module is 433 MHz. The operating voltage of RF module is 5 volt DC. It can carry the weight from 13 kg to 15 kg. It can spray till the range of 3 meters. And 2 important things comes under this is it works on hardware and software. In software we use KELC, and in hardware we use ARM development and U-Link tool. U-Link tool and ARM development can be explained easily in this, but Keel I can explain that it is the same type of programming we do for C and C++, but in this we don't use C programming or C++ fonts like printf and all that. In this another set of programming tool used, that is assembly line programming. Now comes the architecture of this product. Architecture is nothing. What we are going to make, it is a basic sketch of the product. Down we took a steel sleeve. On that we connected the rough tires, and 4 tires we connected with the DC motors. We tried to move on a smooth surface, but it went easily. But when we tried on a rigid surface, like up down surface, at that time it didn't work. So what we did, we took a big tires and rough tires. We took like 2 more sets extra. Total 8 tires we took in total. Then we connected those 2 tires on each side with a pulley. Okay. We moved it on a rigid surface, it worked well. Okay, then we connected it with 4 corners with bars. 1 more slate we kept on the top. Then what we did, using a microcontroller, we used a microcontroller. We can take Arduino also, Arduino Nano, whatever you want to take. Then relay motors we used. With at the side we placed a tank with the relay motors side. Then we connected a robotic arm around it. A robotic arm was connected with a nozzle. A nozzle was connected with a throat. Whenever sensors were there on the side also, whenever sensors used to detect something, that the crops are there, like some little bit of gaps are there in each crop, whenever they used to detect that there is a crop in sideways, they used to move the relay motor, give the sense to the relay motor would pull that spray, and like that robotic arm should move and pull the spray should release the pesticide. This is the basic architecture we have drawn. Now comes the block diagram description. First I will explain you about the block diagram of transmitter. It basically consists of 3 main portions. One is keypad, another is encoder, and the third one is RF transmitter. Keypad is just like a remote which generates signal To control the direction of the moving robot, keyboard has 4 keys. Each key is designed to drive the robot in a particular direction. You can say F for the forward, L for the left, R for the right, and then one more R for the reverse. Corresponding to the receiver, we get the output. There are 4 corresponding output to the receiver which are connected to this keypad. Each keypad is designed to drive the robot on the particular direction. Signals from keypad goes to encoder. The encoder which is used over here is 2 to the power 12 encoders. The 2 to the power 12 encoders are a series of CMOS LSIs for a control system applications. They are capable of encoding informations which consist of n address bits and 12 n data bytes. Each address per data input can be set to one of the 2 logic states. The program address per data are transmitted together with header bits via an RF. RF is radio frequency or an infrared transmission. The capability to select a T trigger on the H12E or a data trigger on the H12A is further enhances the application flexibility of the 2 to the power 12 encoder. From the encoder, it goes to the RF transmitter. From encoder, it goes to RF transmitter. Now you will be thinking, what is RF transmitter? RF transmitter is basically radio frequency transmitter. Whatever signal which is passed from the keypad or whatever button you have pressed, it transmitted to this transmitter. It works at the frequency of 433 megahertz, and then these transmitted signals are received at the output end of the RF receiver. Now comes the block diagram of receiver. It contains so many things. First comes the RF receiver. RF receiver receives the signal from the transmitter depending on the key you have pressed. It also operates at the frequency of 433 megahertz. The current consumption over here is 12 milliamps. Then from RF receiver, it goes to the amplifier. Amplifier amplifies the signals received at the receiver. The amplifier used over here is ULN2803. The amplifier has 8 built-in NOT gates. Hence, the signal outputted from the amplifier are inverted. Then these inverted signals are used to drive the clock. Then the signals are transmitted from amplifiers to decoder. In decoders, they decode the signals which are amplified from the amplifier, and the decoder which is used over here is 2 to the power 12 decoders. The function is totally same as encoders, only over there was they encode, over here they decode. The one more drastic change in this decoders is they use the pair of Haltix series of encoders. From decoders, then it goes to a reset circuit. In this, a low bit MCLR switch is connected to the circuit which operate manually. Now comes the important part, block diagram of sprayer. First we will talk about switching circuit. It mainly consists of relays. These relays are used to control the motor operation, which in turn controls the robot movement. Relays over here are of 12 volt DC. We use like 4 relays over here. Motors which we use are the DC motors which are used to drive the robot. Now comes the camera. Camera is operated with 9 volt DC supply. Now then comes the oscillator. Normally the embedded chip works under the frequency of 4 megahertz. So to generate frequency, we are making the crystal oscillator of 4 megahertz to produce a stable frequency. Then next comes the ultrasonic sensors. The sensor which is used over here are on the both sides of the car. That is one on the right side and one on the left side. These sensors are used to detect the plants. System typically use a transducer which generates sound wave in the ultrasonic range of about 18 kilohertz by turning the electrical energy into a sound wave. Then in echo turn, those sound wave energies are converted into electrical energy. Then the energy is given to the ARM processor. From that, it goes to the main part of this process, that comes the embedded chip. The embedded chip is the heart of this whole process. This is the place, or this is a chip where we write or load our whole program to process the principal operation of this experiment. Now comes the working. In this, keypad has 4 keys. Any one of the keys pressed, then the transmitter has 4 buttons. Those 4 buttons are right, left, reverse, forward. Any one of them is pressed in whatever direction you want to go. Then the receiver has a 4-point output pins for the particular direction. What happens is that the encoded program from transmitter is transmitted to the receiver. Receiver receives that encoded program, then it goes to the decoder. Decoder decodes it and it minimizes the data loss. Now it goes to the sensor part where it sends. There are two sensors, as I told in earlier also. Like one is on the right side, which detects the right side plants, and which is on the another side, which detects the left side plant. What they do is that whenever they detect a plant, they send that process to the ARM. ARM gives the output of logic 0. When it happens that when the logic we don't get 0, we get the logic too high, then it shows that the logic high is delay time. Then it goes to amplifier. Over here the signals are converted from logic 1 to logic 0, and it turn on the first relay. The relay switches over here are used to rotate in whichever direction you want according to the given delay. Then again one more negative signal is applied, which converts or inverts from logic 1 to logic 0 and turn on the second relay. Then this second relay turn on the motor which is present inside the spray tank on, and it starts spraying over the plants. The function over here of camera is that they take the pictures of the plant and tell us about what is the condition of the plant. Is it good or not? Now comes the important part of a product, that is the cost. Over here you are seeing two pictures. One is of a spray which are manually used by the farmers right now, and on the right side you are seeing a picture of automatic pesticide sprayer which is available by some people and which are made by the students. Okay, I will talk about this spray which are used by the farmers. That spray of maximum capacity is available at the cost of 2,200 rupees per piece. And the automatic pesticide sprayer, whatever components I have told, like ultrasonic sensors, sheets, tires, all this stuff, I have used over here and cost them 1100 rupees per piece. You are seeing the totally difference between the cost. And one more thing is, like, if you use that farmer's manually operated pesticide sprayer, some spray pesticide will come on your hand, human skin. It is harmful for your body. Okay, if you are using that robotic or automatic pesticide sprayer, no human contact will come. Only they have to on the server and will start removing. One more thing is that not in the pesticide or in the spray agriculture field, it can be used in the whole world, global field also. Like now, biggest pandemic is COVID-19. Okay, you can spray hydrochloroquine in a whole around. It can be used in that system also. In that tank at the place of pesticide, you are using hydrochloroquine. It's helping people and make people safe. In that all stuff you can use. Cost effect, so many things. If you buy in bulk, like for one piece, it costed me around 1100 rupees per piece. If I get the order of like say 100 pieces, okay, then I will buy so many stuff in bulk. Okay, in wholesale I will buy. So that 1100 rupees thing I will get it in 900 rupees. It's cheaper than those 2200 rupees tank. That's why I'm telling you, as time is changing, agriculture field or agriculture sector should be advanced. That's why I say, at using the manually pesticide sprayer, we should use the automatic pesticide sprayer and let our farmers be in the technical field. Now comes the future's works. Automatic spraying system has been successfully designed to reduce human work. A robot model is flexible. It can adjust easily with crops. In future, wireless monitoring and GSM system can be developed. Why to go that way is future? If we talk about present also, there is a huge pandemic, that is coronavirus. What we can do is that at the place of pesticide, we can fill that tank with hydrochloroquine and we can spray it around. We can sanitize our area. We can make our lives happy, safe. That's all from my side. Thank you.